Right, I just wanted to give you some tips on getting started with this. Um, and you don't have to do it today, but when you have time to get started, I wanted to just help you make it a little bit easier. So basically, the picture that they're showing and the description that they have is you got this airplane, and it starts out at some altitude h, and the distance away the distance it's away from where it's going to land, which is right here, is L. So L is our X is our horizontal distance and Y is our vertical distance. So they describe the path as this curve right here, and they're using P of X to describe that. That's just really your Y value. Just keep that in mind. That'll be easy. They'll make things easier when you get going to remember that that's just Y. And so there's a couple things that they tell you. They're saying that the horizontal velocity of the airplane is constant and it's equal to v. And the airplane's going to the left. So we won't use this for quite a while, but the velocity then is actually minus v because it's moving to the left. That's why it has the negative sign. Going to the right would be positive, going to the left is negative. And just remembering that the velocity is the derivative of the x position with respect to time. This is in the x direction, and that's why it's the derivative of x, because the velocity is the x velocity. Another thing is that the acceleration that they're talking about, the plane can't have acceleration bigger than some value k. That acceleration is in the y direction, and that's going to be the second derivative of y with respect to time. And we'll come back to that in a little bit. But those are just two things that they're describing. So they're saying that you want to describe the curve by this cubic function. And basically, your first job is to try to figure out what all these constants are. The constants you have to figure out what they are A, B, C, and D. Because you want to write them in terms of things that you know about the problem. You want to be able to write them in terms of H, L, and V. And then it could have constants as well. Sometimes it gets confusing when you don't have numbers, but you view these things as things that you're given, so they're like your knowns, and you're trying to express these things, which are unknown, in terms of those constants. And the first thing that they are describing in the problem, the conditions, those are things that are going to actually help you figure out what all these constants are. The first two things are that you can actually see what the value of P is at the two different values of X. When X is 0, the Y value is 0. And the other thing that we know is that when X is equal to L, the Y value is H. So we're going to use these two conditions to try to figure out what some of these constants are. So if we let x equal to 0, and we're going to set that equal to 0, the first three terms just disappear, and we're only left with d. So right away that tells us that d is 0. And so that's kind of nice. We can get rid of that right away. Now using this, we'd have P at x equal L is equal to H. We're going to get A L cubed plus B L squared plus C times L. Right now that's not terribly helpful, but we might come back to it and be able to use it in a little bit. The other two things they told you is to think about the derivative of P of x, which is really just the slope of the curve. And if you notice, at the very beginning and at the end, the slope of the curve is 0. So this is 0 at x equal L and at x equals 0. And that's our other two conditions that we're going to use to help us figure out some constants. So first of all, let's find the derivative. And that's 3ax squared plus 2bx plus c. And then we're going to give it its value of 0 at these two endpoints. So if we look at the slope at x equals 0, and we know it's 0, again, the first two terms here, when you substitute in x equals 0, disappear. And so we also find that c is 0. So we could actually get rid of this part up here. That's helpful. And then p prime of x equals L is equal to 3a L squared plus 2bl equals 0. Because I don't have that third term of c anymore, because I already know it's 0. Now what this will do is it lets me, I know 3a squared is equal to minus 2bl. I can actually solve for a in terms of b. And that will get rid of one of my variables. And so I can take this and put it up here for a, and then I could figure out what b is. And so I'm going to do that in the next slide. Oops, sorry. So I had written that p so I have, well, okay, so I have, what did I learn so far? I hate when I have this screen. A is minus 2b over 3l. And so far I know p of x is equal to ax cubed plus bx squared. Because remember, I found c and d were 0. So now p at x equals 0 was equal to 0. Oh, that's not useful, sorry. We found that p when x was equal to L was equal to h. So I got ax cubed plus bx squared, and I'm going to let x equal L because now I'm spacing out. But I can substitute in for a, so I'm going to have h is equal to minus 2b over 3l, because that's what my a was from up here, times L cubed plus BL squared. And what that's going to do, so I'm going to be able to write that, I can combine that, is minus 2B L squared over 3 plus BL squared is equal to BL squared times 1 minus 2/3 is equal to 1/3 BL squared. So H is equal to 1/3 BL squared. So B is equal to 3H over L squared. So now, where I am right now is I have P of x is equal to minus 2b over 3l times x squared, x cubed, plus 3h l squared times x squared. So this is, remember, this is what I found A was, and this is what I found B was. But here's a B, and I have to substitute that. So I get minus 2/3 over L times 3h L squared x cubed plus 3h L squared x squared. So my P of x ends up to be minus 2h over L squared x cubed plus 3h over L squared x squared. So all I did in this first part, this is just kind of like really getting started, to be honest, is I used the conditions that they told us at the beginning of the problem to figure out what all my constants were so that I could write the curve, which is a cubic, in terms of all the things that I was given. I had to only write it in terms of h and L, and if I needed to, V. And this is what I have. And so that took a long time. And so then what I have to do is next work with this expression and use the information about velocity and acceleration. And that's where that chain rule is going to come into play. So if we go, I'm going to rewrite this. P of x is equal to minus 2h over L cubed x cubed plus 3h L squared x squared. Now P is just your y. And so we already know that dx dt is equal to minus v. That's what I said at the beginning. When we do the acceleration, we have to, the acceleration is in the y direction and it's the second derivative of y with respect to time. But the problem is that this is y as a function of x. So when we take the derivative of y, which is a function of x with respect to time, we have to use the chain rule, and we take the derivative of y with respect to x and then multiply it by dx dt. And the dx dt is just minus v. And then we're going to have to do that again. Take the second derivative again. And so we're going to have to take the derivative of this, do the chain rule, and do it again. I'm going to stop now because this is kind of long, but I'll do a more thorough job tonight, later tonight, but this could get you started.